Hello there and welcome back to our Sydney Proactive studio. We're going over to our Perth studio now to talk to Mike Rosenstreich, the Managing Director of Hexagon Resources. Hello Mike, lovely to see you again.
Thank you very much. Good to see you, Karen.
Now, some very exciting news for your company out with Hexagon Resources entering a joint venture and binding agreement to acquire a significant portion of a US-based rare earth processing business. I believe it's American Innovations Metals. Congratulations on that to start with.
Well, thank you. Thank you.
Can you just start by telling us about the company and what it does and how this JV came about and why?
Well, I'll start at the back. The JV came about from, I attended a session at PDAC in Toronto earlier this year and met a gentleman called Dr. Gareth Hatch, who was doing a presentation on the application of a separation technology called RapidSx being applied to lithium, particularly lithium brines. And I was intrigued by that, and I caught up with Gareth at the end of the session, and we got talking, and we've sort of developed and maintained this relationship. And I think it's fair to say that we've looked for opportunities to work together, and we're very lucky to entice Gareth to become a strategic technical advisor to Hexagon in terms of our graphite transformation. And through the course of all of that and spending this time in the States, I came to appreciate the application of RapidSx to the separation of rare earths. And I think from Gareth's perspective and his company, which is called Innovation Metals Corporation, who developed RapidSx, I think they were sort of intrigued or enticed by the idea of sort of the technical, not the technical, but the commercial and the marketing skills that Hexagon and its enhanced US team can bring to work with Gareth and his team to commercialize this technology. And so American Innovation Metals is the name of the joint venture company that we're going to use as the vehicle for this commercialization process.
Sounds amazing, and we'll get into more detail on that technology in a moment. But just first off, we know there is somewhat of a crisis surrounding rare earth metals globally, and in particular fueling trade wars between the US and China. Did this have any impact in your decision to enter this joint venture, or what was the motivation behind it?
Well, yes and no. I mean, you walked. I've just come back from the States on the weekend, and you walk down the street, and it's amazing people who do know rare earth elements, and they can refer to rare earth magnets and the importance of dysprosium and terbium and neodymium and praseodymium in those rare earth magnets, and the sort of the tension between the US and China. So it's really topical, both politically and on the main pages of newspapers. So that helps, but the real underlying issue is that rare earth production is dominated by China, about 80% of the world's supply, and rare earths are such a critical element if we want to have a low carbon environment, for example, in terms of renewable energy, electric vehicles, the devices in your smartphone, and also some very specific military applications. And to have that sort of vulnerability to a country that has in the past flexed its muscle in terms of supply or not supply is a topical and concerning issue for places like the United States and Australia and much of the Western world. But the key thematic that really sits in behind it, which creates, I think, a sustainable environment to base this business on, is that production of rare earths is declining in China. It has environmental issues associated with it, and the Chinese authorities are enforcing or cracking down on those issues. And so we are, fundamentally, we're seeing very strong surge in demand, and we're seeing this declining production, and that just creates a wonderful opportunity for us to work on a technology which I think addresses the sustainability issues and the cost issues associated with rare earth downstream processing, and would make it available to a whole range of countries or developers outside of China.
So tell us more about this technology, because as you said, the focus of this joint venture will be on the development of the RapidSx technology. In simple terms, can you break it down and tell us what it is, what it does, and why Hexagon Resources sees so much potential in it?
Well, I'm sorry to correct you, but the development is actually largely intact, and it's a really important aspect in terms of where we're coming in on that risk profile. But so we're really involved in the commercialization of the technology. So RapidSx is using a solvent extraction process. That's where you're taking two liquids, in this case an aqueous phase or an acid which has got dissolved metals in it, and an organic phase. And basically those two liquids interact or interface, and the metals that you're looking to concentrate are plucked out of the aqueous phase and captured in the organic phase. And then the organic phase settles out and gets stripped, and you concentrate these metals into oxides from these very dilute solutions. That is standard solvent extraction. Now what RapidSx does is it creates a mechanism where that interface between the watery or acidic aqueous phase and that oily organic phase is much more efficient. And so that plucking of the metals, that extraction, is seriously enhanced. I call it SX on steroids. And that's the secret to RapidSx. And that's why it's being looked at. You know, it's certainly been proven with rare earths, and I'll come back to that point if I may, but also being tested with respect to nickel cobalt separation, and also taking lithium from these very dilute brines and extracting them in a commercial way rather than evaporation. So when I refer to proven and commercialization, what I mean is that Innovation Metals Corporation, our joint venture partner, actually received $1.8 million from the US Defense Department to pilot RapidSx on the separation of rare earths. And they were able to deliver that project on time, on budget, and with outstanding technical results. And so on that basis, there's a lot of risk issues in that piloting phase that have been addressed, and we're now ready for a commercialization phase.
So how does RapidSx help to address that rare earth supply chain pinch point?
Well, the pinch point is in the downstream concentration or separation of these rare earths. At the moment, that happens in China with these vast arrays of solvent extraction units, literally hundreds of these circuits, each of them working to separate 17 odd different rare earth elements. Now, RapidSx enables that footprint to reduce by something like 90%. It reduces capital costs, it reduces the operating costs because you have a much less metal in inventory, and it means that the whole process is far more contained, we're getting higher purities and more efficient. So with those lower operating costs and those lower capital costs, it makes it accessible for current producers and also people with advanced emerging projects.
So it sounds like it's been very well tested and proven, but is this a brand new technology? And if so, isn't that high risk?
Well, I spent about 6 years working on the dark side in the banking industry. So one of the things bankers hate is new technology. This is an enhanced technology, sorry to be pedantic. And it's really important because the fundamental scientific principle is liquid-liquid separation, as we've had in the minerals processing and other industrial processes for a long time in standard or conventional solvent extraction. So the science is there. All that Gareth and his team have done is enhance the mechanism of that liquid interface to come up with this supercharged version of solvent extraction. So I think that addresses a lot of that risk, as does that piloting work funded by the US government that I've referred to.
So can you tell us, why would someone look to adopt RapidSx rather than the conventional SX route?
Look, as I alluded to a little bit before, because of the capital cost reduction, if you can reduce that footprint and the number of mixer settler units by 90%, that's a massive reduction on capital spend. There are other operational efficiencies, such as because you've got faster flow through the circuit, much lower metal inventory, so that's an operating cost saving, aside from the saving that you're not running hundreds of these agitators and things. And finally, there's also just the lower sort of inventory in terms of reagents and things like that.
So what will this joint venture announcement mean for shareholders, the all-important question?
Well, we're very much on a commercialisation path. And I think what it means for shareholders is that we're delivering into some earlier announcements where we've said that we're interested in energy metals, we're interested in opportunities that are able to be commercialised quickly. So here we have a demonstration plant that we are looking to fund, which will then be generating somewhere around 60 to 80,000 kilograms of separated rare earth oxides. Now that plant will work on a fee-for-service basis, but also it will lead to licensing agreements. So that's the sort of pathway to commercialisation. And there are also opportunities in the US. We may be invited or eligible for various government grants to sort of accelerate or feed into that commercialisation process. So what shareholders can see there is almost a significant equity stake in what will be really a self-funding business after our initial investment.
Sounds great. And how will the joint venture impact Hexagon Resources' strategy and focus moving forward? And what are the next steps?
So that's the strategy and the focus. And I think the next steps with respect to the rare earths are now to enter into agreements with producers of rare earth concentrates so that they're able to provide product or samples to go through the demonstration plant, and that will lead to licensing agreements. There have already been several confidentiality agreements signed, so people are very interested in the opportunities that this technology brings. I'm confident that in a short period of time, we'll have a range of materials lined up, ready to go through the demonstration plant. We're looking to have the demonstration plant up and available in about Q2, Q3 of next year.
Big news and exciting times for Hexagon Resources. Mike Rosenstreich, thank you so much for your update today.
My pleasure. Thank you for your interest.
Thank you. That's Mike Rosenstreich from Hexagon Resources.